All right, so this is 8.4 part 2 using the point slope formula. Remember that point slope formula we've already learned is y minus y1 equals m parentheses x minus x1. Okay, so we're writing the point slope form of the equation with the given slope that passes through the indicated point. So our slope is -2, our x coordinate is 4, and our y coordinate is 1. So remember, the minus part is always in the formula. So we would have to start with y. So y minus our y value, which is 1, equals our m, which is -2, parentheses, x minus our x value, which is 4. And that's all you need to do to write that equation. Okay, number 2. We have a slope of 5 passing through the point -2, 4. So the y value is 4. So y minus 4 equals our slope, which is 5, parentheses, m minus, not m, I'm sorry, parentheses, x minus our x value. So we have to have a double negative here. So remember, when we have a double negative, that equals a positive. So 5 parentheses x plus 2. Okay, so number 3, you have a y value of -2. So again, we're going to have a double negative. Y minus a -2 equals m, which is 4, parentheses, x minus 5. So we need to correct that double negative, make it a y plus 2 equals 4, parentheses, x minus 5. Okay, number 4. Same process again. We have a line with a slope of -5 passing through -3, 7. So y minus 7 equals, our slope is -5, parentheses, x minus our x value. So we need to correct that double negative. So y minus 7 equals -5, parentheses, x plus 3. Okay, number 5. Suppose that a laser eye surgery is modeled on a coordinate grid, like a graph. The laser is positioned at the y-intercept so that the light shifts down 1 millimeter for every 40 millimeters it shifts to the right. Okay, so that just gave you a slope. Notice it said down and right. So that would be like rise over run. So if it's going down, remember it has to be negative. So negative, it said it went down 1 millimeter. Right would be positive, and it said it went right 40 millimeters. The light reaches the center of the cornea of the eye at 125,0. So that's giving us a point. Write the equation of the light beam in point slope form and find the height of the laser. So the height of the laser would be represented by the y-axis, right? The y-intercept. So what we're going to need to do is find the y-intercept. So we're going to write this equation. So y minus our y value, which is 0, equals our slope, -1/40, parentheses, x minus 125. That should be a minus right there. Okay, so now what we need to do is find our y-intercept. And in order to do this, we need to do what we've done before, which is substitute 0 for x. So y minus 0 equals -1/40, parentheses, 0 minus 125. Okay, so we're going to do some simplifying here. So we don't really need that y minus 0 because it would just be y. And then we have -1/40, parentheses, -125. So those two need to get multiplied together. And that would give us y equaling a positive 25/8. So that would be the height of the laser at 25/8.